Okay, good morning and welcome back to the Business First stage, presented by IFT's Food Technology Magazine and the Omnivore Podcast. Great to see you all here this morning. Thanks for joining us. My name is Bill McDowell. I'm the Editor-in-Chief of Food Technology and the Vice President of Content Strategy at IFT. So today, we're going to talk about the ingredient sodium aluminum phosphate, which has long dominated baking formulations as a leavening agent. But as food manufacturers are increasingly moving toward clean label products, the need for viable substitutes has become paramount. So this morning's presentation, a clean label alternative to sodium aluminum phosphate for today's bakeries, will feature Paige Neher, who is an associate scientist for Innophos. Paige is going to introduce us to a new leavening agent that rises to this challenge. We'll have some time built in at the end of Paige's presentation for Q&A, so hold your questions until the end. But for now, I'm pleased to introduce Paige Neher. Paige?
Thank you, Bill, for the introduction. Hi, everyone. Today, I'll be telling you about a clean label alternative to sodium aluminum phosphate, which is commonly known as SALP. As many of you may know, SALP is a versatile leavening agent used in a variety of baked goods. However, it contains aluminum, and concerns have been increasing around aluminum in the diet. But because of SALP's versatility, it's been really hard to replace. Today, I'm excited to share an innovative new non-aluminum leavening technology that performs just like SALP to address manufacturer and consumer needs. First, I'll briefly introduce myself again. My name is Paige Neher. I'm an associate scientist in food and beverage applications with Innophos. I mostly do research and development as well as new product development in our lab in Cranberry, New Jersey. And a little brief background on Innophos. We are a global producer of essential ingredients to improve quality of life. We have over 100 years of expertise in leavening solutions, and we have markets in bakery and snack, as well as beverage, dairy, and meat, seafood, and poultry. We also have locations all across the world in US, Canada, Mexico, and China. So in this presentation, I'll first discuss the market opportunity surrounding a replacement for SALP, followed by the science, why leavening technology is important, and why SALP is so versatile. And then I'll introduce our clean label alternative, LEVAIR Select, and its characteristics as they compare to SALP. And then I'll delve into a few case studies to compare the bake performance of the two products. Finally, I'll talk about the value proposition of LEVAIR Select for both consumers and bakers. Please feel free to ask any questions you may have at the end of the presentation. I'd like to start by talking about the market opportunity that a functional alternative to SALP presents in the bakery world. Consumers have been increasing the pressure for bakers, retailers, and manufacturers to remove aluminum from their products. This is because they are becoming more informed about the potential health implications of aluminum in the diet. As a result, health-conscious consumers are seeking more clean label solutions, meaning that they don't want to see aluminum on the label. This increase in labeling transparency and awareness has played a major role for the need for aluminum-free alternatives. People in the industry have been adapting to the pressure by reformulating their products. If you look at the graph, you can see that from 2020 to 2022, there has been a 10% compound annual growth rate in global launches of bakery products and mixes containing aluminum-free leavening. This is demonstrating how consumer pressure has really been influencing the industry. Along with influencing trends in the bakery industry, consumers are also driving regulatory changes that suggest shifting away from aluminum-based leavening. These regulations have been widespread and consistent and are furthering the need for an alternative to SALP. The changes started in 2014 when the European Union submitted regulations specifically to address the aluminum content in food ingredients. The aim was to establish and enforce maximum levels of aluminum that could be present in foods to better align with health and safety considerations for consumers. And for the same reasons, in 2019, Mercosur nations in South America banned SALP in self-rising flour. And again, in March of last year, Health Canada proposed restrictions to remove aluminum from the list of approved additives. These regulations in Canada are still pending, but if you sell your products in international markets, then these regulations are likely already affecting you, or they will in the future. At this time, the regulations have not yet reached the US, as SALP is still generally considered safe by the FDA when used for its intended purposes and following good manufacturing practices. Though the regulations are not yet here, what is here is consumer demands for aluminum-free alternatives. As a result, many US retailers and manufacturers are proactively removing aluminum-based ingredients from the products on their shelves today. Among these retailers are Whole Foods Market, Wegmans, Panera Bread, and Trader Joe's, four big names that you've probably heard. If we continue to see retailers and manufacturers in the US demonstrating a commitment to meeting consumer demands for aluminum-free alternatives, then we're likely to start to see changes at the national level. Now let's explore the science behind the leavening acids in baking powder and how an alternative leavening acid could match the performance of SALP. Selecting the correct leavening acid is important for many reasons, as it's tailored to the specific requirements of different baked goods. Leavening science studies the agents that generate gas to expand a dough or batter during 3 stages: mixing, bench time, and baking. These agents include different leavening acids as well as baking soda, which react to produce carbon dioxide, or CO2. This CO2 production is what causes your bakery products to rise and contributes to the final characteristics of your product, like volume and texture, which create that desired eating quality. For example, frozen and refrigerated products typically require slow-acting leavening acids because they need a slow and controlled release of gas during thawing and baking to ensure proper rise. And more importantly, you don't want to lose any of that CO2 during the time that the dough is in storage. Next, muffin and cake type products typically require medium-acting leavening acids because they need a balanced release of gas to ensure proper rise during longer baking times and prevent overexpansion in the oven. Finally, griddle type products like pancakes typically require fast-acting leavening acids because they have shorter cook times and need to start producing gas and bubbles in the batter while it's mixing. Overall, slow and medium-acting leavening acids release most of their CO2 in the oven once exposed to heat, whereas on the contrary, fast-acting leavening acids release most of their CO2 before this point during mixing and bench time. Building on the idea that different leavening acids have different speeds, I'll now go into more detail about some specific ones. There's a way to measure the speed of the leavening reaction, and that is called dough rate of reaction, or DRR. This curve indicates the percent CO2 release over time for a leavening acid as a direct result of its reaction with baking soda to produce carbon dioxide. This is measured in a closed system at a controlled temperature of 27 degrees Celsius to signify typical room temperature baking conditions. Here's an example of a slow-acting leavening acid. This is sodium acid pyrophosphate 22, or SAP 22's curve. The 22 comes from its percent CO2 release at 2 minutes of reaction, and for SAPs, the higher the number, the faster the reaction rate. Because SAP22 has a slow release of CO2, it works well for cold stored products. Next, here is SALP's famous curve. It has a more medium-acting range of CO2 release, but it's heat reactive, making it suitable for muffin and cake type products. Although its curve is a little bit faster than SAP22's, it still releases most of its CO2 in the oven. Finally, here are two fast-acting leavening acids, SAP40 and the fastest, monocalcium phosphate, or MCP. MCP releases about 60% of its CO2 in the first 2 minutes of reaction. And because these are fast-acting leavening acids, as I mentioned earlier, they work well for griddle-type products. Now, these leavening acids can also be used in combination with one another or with other leavening acids that are not shown here. In this case, it is called double-acting baking powder. And SALP is often used in combination with other leavening acids because it has a curve that makes it ideal for achieving that CO2 release that you need for a lot of different types of products. For example, it's often used with MCP, and in this case, the MCP will start producing gas and bubbles in the batter during mixing and bench time, and then SALP will work in the oven to set this structure. Now, you might be asking yourself, what can happen when you use the wrong leavening acid? How will this affect the final characteristics of your product? Well, this cake here on the left has been made with MCP, which is a suboptimal leavening acid for use alone in a cake application. As a result, this cake appears dense and sunken and has not achieved that proper rise because a lot of the CO2 has already been lost before it even entered the oven. On the contrary, this cake here on the right has been made with SALP, which, as I mentioned earlier, works great alone in a cake application because it saves a lot of that CO2 for the oven. As a result, this cake has good rise, open cell structure, and soft, springy, and resilient texture. I've talked a lot about different types of leavening acids, and now here I'd really like to emphasize how SALP stands out from other leavening acids. Its DRR curve here on the right is part of the reason why it's extremely versatile. It has a low initial CO2 release for high bench tolerance, which I'll explain more about later. It's also heat activated for an even rise in the oven, and it has delayed reaction in cold stored products. And for all of these unique reasons, SALP creates a soft, springy, and resilient texture in all of the different types of products it's used in, like cakes, biscuits, donuts, muffins, and frozen dough. Therefore, SALP's uniqueness really lies in its versatility. By now, it's clear that SALP is used in a variety of bakery products because it's an extremely versatile leavening acid. However, it happens to contain aluminum, and concerns have been increasing around aluminum in the diet. People in the industry want to be attentive to these concerns, and they need to comply with emerging and existing regulations. This means that you need a solution. And in response to this need, I'm excited to introduce to you today LEVAIR Select, a new non-aluminum-based leavening solution. As I'll demonstrate, LEVAIR Select has very similar performance to SALP while helping to meet consumer demands for cleaner, healthier labels. It also addresses regulatory requirements where applicable, and like SALP, it can be used in a variety of bakery products. So, these two slices look like two halves of the same cake. Can any of you guys tell the difference? Well, I'll tell you now that this half has been made with SALP. Here are its characteristics. Its DRR at 2 and 8 minutes to signify low initial CO2 release, as well as 3 pluses to indicate its high bench tolerance. And at the bottom are its sodium and calcium percentages per 100 grams. And this half, I think they kind of gave it away in the beginning, but this half has been made with LEVAIR Select. It has very similar characteristics to SALP, but seeing is believing, and you can see that these two halves look nearly identical. It also has added benefits like reduced sodium and significantly more calcium. Now, this is your third time seeing SALP's DRR curve, and I promise there's only one more after this. But I show it again to really demonstrate how similar SALP's curve is to LEVAIR Select's. And because LEVAIR Select has very similar DRR at 27 degrees Celsius to SALP, it is also ideal for all of these products listed here on the right, like cake mixes, self-rising flours, donuts, sponge cakes, and muffins. I briefly mentioned earlier how SALP also performs well in cold-stored products because of its low initial CO2 release. We wanted to test this by performing DRR at 5 degrees Celsius. And we found that under these refrigerated conditions, both SALP and LEVAIR Select have less than 5% CO2 release, making them both ideal for use in frozen and refrigerated products. Yet another reason for SALP's versatility in the bakery world is its high batter bench tolerance. A batter's bench tolerance is an indication of how much CO2 is being released after mixing while the batter sits out on the bench or moves throughout the bakery line. Loss of CO2 during this time can have negative characteristics on your batter as it moves through the line, as well as on the final characteristics of your product, as I demonstrated earlier with the MCP in a cake application. To measure bench tolerance, we measured batter flow and specific gravity directly after mixing, and then after holding for 20 minutes at 38 degrees Celsius to signify extreme conditions in a bakery. And this gave us a percent change for each parameter. Here are SALP's results: less than 8% change in batter flow and less than 12% change in specific gravity. And LEVAIR Select is also very tolerant of ever-changing bakery conditions. Now I'll share with you 3 case studies to examine the bake performance of the 2 products, in cakes, biscuits, and donuts. And in these case studies, I'm really going to be emphasizing how LEVAIR Select performs extremely similar to SALP. The first case study of the 3 is yellow cake. As you can see, the objective here is to study the impact of substituting LEVAIR Select for cake in a cake application and determining how this will affect the final characteristics of the product, like texture and volume. First, I'll explain the methodology, and then I'll go through the results. So for texture, I've reported firmness in grams, measured using the standard texture profile analysis method on a texture analyzer. Higher firmness values indicate denser crumb structure, and lower firmness values indicate softer crumb structure. And for cakes, you need a balance between soft texture and good rise in the oven. So for volume, I've reported specific volume in centimeters cubed per gram, measured using a laser volume profiler. And here are the results for SALP. These are exactly what you'd like to see in a cake, and SALP helps you achieve that. And the cakes made with LEVAIR Select also have the ideal characteristics that you'd like to see in a cake application. The second case study is on biscuits, where the methodology and the objectives are the same as in cake, but this time we have height and volume. So height has been measured manually and reported in centimeters. And for biscuits, you need a tall and expanded structure to maintain that internal fluffy texture. And the biscuits made with SALP help you achieve that, the ideal characteristics that you'd like to see in your biscuits. And LEVAIR Select, again, little to no difference in these key parameters. The last case study is on donuts, where everything here is the same as in yellow cake. But donuts are very different from yellow cake. You actually need a lot more firmness to achieve that proper bite and mouthfeel. And you can see that these values for firmness, the scale is a lot larger than for yellow cake. And this needs to be balanced with a good puff in the fryer to maintain that structural integrity of the product. And again, it's repetitive, but SALP has the ideal characteristics in your donuts, and LEVAIR Select, little to no difference in key parameters, maintaining, again, exactly what you'd like to see in your donuts. The baking industry has known that it's not been easy to replace SALP given its versatility. So there has been a strong need for an alternative that performs the same. And I've demonstrated how LEVAIR Select has similar characteristics and also performs extremely similar to SALP. And now I'll summarize its value. LEVAIR Select offers benefits for both consumers and bakers. For consumers, it responds to their health concerns surrounding aluminum while maintaining the ideal characteristics that they know and love in their baked goods, so they're not compromising anything. It also offers them more calcium and less sodium in their bakery products. And for bakers, LEVAIR Select provides you with a non-aluminum alternative to help keep your consumers happy, while maintaining the same characteristics in your batter to maintain bench floor and line tolerance. It also performs the same as SALP from mix to oven, so you end up with the exact same product at the end of your line. Thank you again for joining me today to talk about a clean label alternative to SALP, LEVAIR Select. And don't forget to find us in meeting rooms 5345 and 5346 to learn more and get your complimentary Monte Cadas muffin featuring LEVAIR Select in the back. I can see some of you already got a sample, but we have more in our meeting rooms as well. So thank you.
Excellent. Thank you, Paige. That was fantastic. We do have a few minutes for some questions. Anyone have a question? You can go ahead and raise your hand. I'll bring the microphone over to you. Oh, we've got one. Hang on.
Oh, okay. Can you hear me?
Yes, I can hear you.
Is there any value to using LEVAIR in something like the pancakes?
Yes, so LEVAIR Select, if you have SALP in your pancake, it's probably used with MCP in that double-acting baking powder. So you can just take out the SALP and put LEVAIR Select in there. We haven't done any work just using LEVAIR Select in a pancake. It might work for some applications, but usually you need to use MCP alongside it.
Paige, I have a question. You talked about the textural components of the rise and everything, but are there any flavor or taste implications to this? How does it compare?
That's a great question. We actually have a trained sensory panel at our Cranberry office. So we've done plenty of tests, and we have found that there is no noticeable differences in flavor between SALP and LEVAIR Select. It's a very clean tasting, no added flavor product.
And how about other applications for this outside of strict baked goods? I mean, have you tested other applications?
Yes, so I mentioned earlier about how SALP is used in cold stored products. We've actually compared LEVAIR Select and SALP in a tempura batter application, so you need to keep everything cold throughout this process, and we found that LEVAIR Select performs similarly to SALP in this application. We're also exploring pizza crusts. We're constantly expanding these applications, but we have done a few more than I've shown here. Mm-hmm.
Fantastic. Oh, we have another question.
How does it appear on an ingredient statement?
Yes, that's a great question. It appears as calcium acid pyrophosphate and monocalcium phosphate.
Thank you. How would you compare usage rates of LEVAIR and SALP?
I didn't go into detail about this in the presentation, so we could talk more later, but I'll just say that leavening acids have different neutralizing values. If you're familiar with SALP, you know that it is 100, so you just use it at the same level as your baking soda. This does have a slightly lower neutralizing value, so you do need to use a little bit more to achieve the same parameters.
Excellent. Let's all give Paige another round of applause. Thank her for a great presentation. I also want to acknowledge that Innophos is a bronze sponsor of this year's IFT First, so we really appreciate your support for this event.